on this side. Yeah.
Okay, it works. Thank you very much. So this topic towards construction circular economy, and we all have started. My career started. I did a PhD at Monash, late 80s. I was working as an engineer for it's okay, not Arabs, but Conal Wagner for about 5 years, and now it's Oracon, of course. But at that time, also introducing some of the newer materials. I'm actually taking the credit now, but I'm proud of it, introducing high-strength concrete in Australia for the first project in Australia, the telecom corporate building. We went to 65 MPa. So we were thinking about sustainability even at that time, late 80s, early 90s, when we were designing these number of tall buildings at that time. So it's not a really new thing, but what has happened now is really it's changed the whole landscape. And I've been traveling a bit after COVID. I thought of traveling to a few places. And so I've known a bit of landscape 2 weeks back in Perth also, and last week in Sydney, Canberra, but talking about these topics. And I think it's a really, and also Richard and myself, we were there today in the Ecologic conference, and you see the huge interest there. Anyway, I will not take too much time because on that. So it's a timely topic. We all are interested in that. Of course, we don't need to really spend time. We know what's happening to the ozone layers and and so on. So we need to do something now. And this is real. The carbon dioxide, we know the parts per million. See it rising. This is before 2005. It's even rising at a rapid rate now, even more than that. So we need to do something. There's nothing. It's all it's evidence. There's scientific evidence there about these changes. And the temperature rise also, actually we were not sure at that time, but now when you draw these graphs and so on, it is happening. It's really nothing to really argue or anything. No, it's not happening. But this is really, we shouldn't believe too much, everything to Mark Linus' book. Actually, we have a chance, we can go through that. It's very interesting reading, but he's saying 6 degrees, but what happens in 6 degrees is the world will basically, according to him, we won't have humans after 6 degrees. So I think maybe it's one extreme view of things, but however, it's not the 6 degrees or anything. We need to stop that. So that's why these things are happening. We know that there are natural disasters, droughts and the floods, all happening in different parts of the world, landslips, all that are there. So that's why I think it's very important thing happened. Everything turned around from this Glasgow COP26 event. We had Paris, Kyoto's, everything. But this is the one which changed the world. So even the landscape, if you, we all met just before COVID, I was really representing Australia in the ISO meetings, the code, the concrete code. But at that time, we were talking about the low carbonization, and we were trying to put it to the codes there. But now, at that time, we didn't have all that as well. But now, the last 6 months, we know how the landscape has changed. So we can't avoid that. So today, it will be a blitz of a presentation. I'm sure we're doing lots of work on this, so I won't be able to present everything today, but I'll have a bit of a snapshot of what we're doing so that you can really, there are some of my group also here, but you can also really contact us and we can work together on some of these issues. We need a collective effort. So this 2015, the net zero target, actually we all know what is net zero, but the targets are to have these emissions reduced to net balance to be zero. It's not easy. And we had the federal government had before in 2030 the 35% before, but now I think Mr. you're also responsible for some of those policy writing, but the 43% now the 43% target in 2030. So which really is not easy to get. I know we all have to do something, otherwise there's no way. We are still 15% or whatever, 15 to 16, 17, 18%. So are we going to reach in 7 years' time in 43%? So that's what I'm going to say today. Anyway, these are all, but it's very important to happen. And also this number is quite important. I know I have to speak to that, but I think there's here. But this number, the 100 billion. So it's a lot of very important that that number. The reason is that will be a driver as well. There are a lot of finance around for this, and this is the one which will change. It's not just we are going saying and you all have to be sustainable structures, construction, circular economies, all that. But these things will change. So businesses already banks are not really lending any money to any project if they are not really towards a net zero. So it's what I want to say here is really encouraging that way that things are happening, where we have been trying this for a long time, but now there are incentives for us to work. And the engineering and all the other professions related to construction sector will gain from that. So having some extra knowledge is a key for everything. Everyone can't just do that. Take our context, the construction and demolition waste. We have, these are numbers. We can circulate this presentation later on. You don't need to take down any of these numbers, but they are all actually available in the available as well. 44% of the total waste generation in Australia. This is construction and demolition waste, and we have so much happening in our space. And I mentioned the climate change bill, which is really it is legislation now, so it's really like even the Greens are supporting, so it is really great. So it by 2030, and then it's by 2050. Looking at the numbers, we are also doing some calculations. It's not easy at all. So we all have to work together. So this really actually we all know a little bit, but thank you to those in the audience who put together the diagram for me. With the linear versus circular economy, which it's a simple concept. We were all at that time when you were designing, we were just using linear production, consumption, disposing. Even at homes we were doing that. But now we are into a bit more. Of course, the circular economy where production, consumption, waste management is there, and then coming back to all the raw materials. We are running out of raw materials. So, but that innovation is very important. When you put innovation investment, is quite important. It's all about dollars as well. Olga, I think, in the audience as well, doing a PhD on the circular economy with us as well. So it's really, these are very important topics for the future. So it is really the three principles which are driving, which are relevant to us. So we have to eliminate the waste generation and pollution. So to reach the net zero, there are two main things: are the renewable energy and the raw materials. We call it the recovered resources rather than, some people don't like to use the word waste materials. Yeah, recovered resources, the word that we should be starting to use. So the circulate again materials used at the highest value, designed for reuse. That's a term we will know when we started prefabrication. We used the word designed for DFMA, designed for manufacturing and assembly at that time when you started the prefab so many years back. But I'm starting to say that now designed for circular economy or designed for circular construction, because that is the one which will really early stages of design, working with the clients, working with architects, everyone in a project to really come up with to thinking about the whole the life cycle, because we can't. Even Singapore is happening. Singapore, you need to give really you need to show a plan how to dismantle as well at the end. So it's happening, and at the end. So here, I think it's going to come, and we have been started. I know at conference we already started. The dismantling is demolition can be, but then you can demolish the building, but building or infrastructure. But you need to give a plan how you're going to give the materials. How are you going to do that? Those calculations, the life cycle calculations had to be done. So it's coming in a small way. I have seen at least one project here, so which they've been talking to us, but at the moment I'm not allowed to name that. But so it's also, I think what's happening is for when you go for bids and so on, tenders, and someone giving that whole plan would have a bit of edge. It's coming, really. It's no doubt about that. So that's why good to know all these things. But my last slide was on quantification as well. But quantification is quite important, where you need to start looking at the numbers, not just talking about how some waste materials go and use it in the projects. But so the third one, which is really we can't eliminate the natural resources, but for example, like sand, which a number of people, including us, doing lots of work trying to, I'll say only 1 or 2 projects today because of the time, but even the glass, we are doing lots of work. But so there are challenges. We can't just use that. So natural resources, if we can avoid having rivers and all that natural resources, it'll be very good. So this is what I started, at that time, 5 years back. We got an Australian Research Council hub, the prefabricated. It was the thing at that time. We were starting the prefab box to many other things together. But and then I was leading that center. So we have a project. Even we're thinking about at that time also prefabrication. My message, as I said, to be very quick talk today, but even prefabrication is a very good example of the circular economy. I'll mention the reasons for that with some examples of that. Of course, the details are there of the center. The prefabrication is going in a big way. Simply, you do that, we already, at that time, 5, 6, not 10 years back, we were doing new things, but now that is becoming, lots of things are becoming routine as well. Not even with us, so many people have gone through, students to many others like this. I think I started this about 7, 8 years back. But done in a factory, bring it to of course, transported and really put it in place. So the full, this is a very good example of where it can be dismantled, where once it's done, we just take it out and relocate it, or some other things can be taken to the factory and really be reused and all that. So this is going to be even more popular now. With there were some cost issues at that time. We were also working on banks were not even I had a project on the banks were not even giving funds because we are used to houses being built. Again, I didn't take it too much time this experiment. The banks were not giving money at the moment. We have the stages and we get the money, the loans come from the banks at different stages. But the banks were saying, because upfront you need a lot of money here, upfront to build the structure in the shop or the factory. So banks were not giving that money upfront because they want to see the product. So that was one of the projects. But now if you go to a bank, they will say, if you put it circular economy and all that, and I think this shouldn't have any problem. So the landscape has changed a lot, I can say that. And so it's a positive way. Those who are new to some of the prefabrication, it's really like modular means a 3-dimensional. The panels we use in buildings and other places, they are 2-dimensional, prefabricated as well. Panels could be part of it. But when you say modular, it's really like more 3-dimension, like the whole box will be built, and we know even the pots and all that are really inside now. Bathroom pots to kitchen pots, all that are done in the factory, and then we don't really know, they all are done in like this. So in prefabricated, and so it is getting very popular when we can do the foundations while the structure is being done in the factory, and so it's very quick construction. And I'll give some examples today. There are a few YouTube talks of mine which you can go through a bit more detail as well. So it's really the reusability is there from the beginning, and the minimization waste was one of the drivers to take up this modular construction. So we have thought about even at that time. So I'll run through a bit quicker. My start to this area was we had to acknowledge Nanda Castellis at that time started the thinking here about these systems. and it is not easy as just put it like that. But this Russell place was done in 6-7 days, done in a factory and brought in. He initiated a lot of things. So we were helping with even the environmental calculations to other things at the beginning, working with him. And the next one there is really one which really we all know, the Latrobe Tower, which is there's a lot of people come, and I know Dr. Shankumar, I think should be listening online. He came up with this with Hickory and the Latrobe Tower, the design, all modular, and there are some YouTube videos of how it was constructed. It is the tallest properly done modular building in the world. So it's I think it's about 40 stories, but it is still, there was another, again, I'm trying to say all these stories, but there was another building being built not too far from there. And that started even earlier, but then this started late and got completed first. Also, first time Melbourne nighttime construction was allowed, and there were some noise rules first, slightly relaxed. So there were some changes, but it's a record. It's very good for us, Melbourne. It's been talked about in many forums now. So this is really working with pre-built in our center. One of the partners, they have done houses, and then there are some examples. I got many examples, but again the beautiful houses. So it's not just the boxes. There's a saying that it should be just containers, but it's not just boxes. So it's really, and again retail facilities, the McDonald's to the schools. The schools, as we know, they're all now compulsory to have modular. Again, those are new to this area. The students, the disruptions we had are all not there now because when they go on the 2-week holiday and when they come back, there's a brand new school building now. So it is really delivering that, and the less disruptions, all that. So we have all, they're all compulsory now in Victoria. Victoria is actually lead the way in many things, and New South Wales has followed that. So many schools have been done. We have gone and done some monitoring to many other things, working with the companies on these railway stations. We know when we go after work on Friday evening, and there's a brand new railway station when you come on Monday. So it's changed the world. Actually, it's really good. So I'm very glad to be involved in some of those things. But so these are it's done during the weekend, no disruptions, all that to what's going on. The healthcare is obvious, medical, and even some of the medical facilities, and the quarantine center was done in Melbourne. You see some of the modular techniques, these techniques. These are all very quickly can be done at the police station. So many examples we can give and been in there. So it's very quick one is post disasters. There are disasters to really do it very quickly. Other things are remote areas. There are remote areas we can't go and construct very quickly. So to do them in a site, in a factory somewhere else, bring it in there, it's quite important. We work with the Foreign Affairs as well about this one. So we are, because we are linking this is the best example. I'm quite fortunate to be in this area leading that, and now getting into a lot more onto the circular economy side. But the offshore construction, the demolition, then the modular design enables not only offshore construction, but offsite demolition as well. So the future disassembly, as I said, we need to think about how to disassemble the systems as well and reuse them. And so that's really a good example. So we'll see a bit more prefabricated, not only the in situ could be there still, but my thinking is about another 10 years that we will have mostly prefab, not prefabricated construction, will be done on site. Even the concreting we'll do, we have techniques now, as we know. So this is quite important. We think the buildings as material banks, which with lots of materials are there, like a bank. And then think about, where do you spend this money? Like we are spending money, plan it. Where do you spend this materials. Where do we put these materials? So it's it's quite important concept. So I'll move into that. So it's a very brief prefab, and if there are any questions, I'm happy to answer on prefab. Been there for a bit of time. With the recycled materials, the applications. This is the another hub that myself and the Professor Setung in RMIT started. This one called the ARC TREMS hub. The Arabs is actually, I see the Arab side. Arabs is a partner of this as well. So ARC TREMS hub, the transformation of reclaimed resources. That's the name I think I gave, into engineered materials and solutions. At that time, the iron was not that hot, but when we started this, but now as you see, there's a lot of interest in this one. And we did a bit of plan for all materials, and this is about 3-4 years back we planned, but now the center is starting now, basically. If you're interested, thamesnetwork.com will give a lot of details, and there are a few other units, but mainly led by RMIT and the Melbourne side. So there are themes. I will not spend too much time. These themes really give us the whole picture what we have to do. So it's really the social change. We need to really, the habits, the social change has to be done, we know. So that's we cover in the first theme. And we need to go and do the processing and the resources. With the processing side is quite important. And then to think about the theme 3, which smart materials, products, and solution development. I personally, I'm the team leader for that, in addition to being deputy director of the overall center. But so the fourth one, which we talked a lot in the conference yesterday and today as well, is the evidence base. Now we need to have the evidence to use them. Some people are saying it takes 10 years for a recycled material to come to the market. So it's really the field trials, the case studies are quite important. So that evidence-based, scientific base is quite important. We don't have that all. So that's where I think we all have to have a collective effort. This is really something that has to be done very quickly. So anyway, the waste materials, this very quick one, the concrete is obviously one of the main outlets. And we should be talking about concrete as a dump, the sink for all these materials to be dumped and the waste materials. It has to be the other way around. So I'll give an example because I wouldn't have time to explain. Let's say we are going and putting some material, like now I'll have a couple of slides on, we are trying, the last project we did with the Metro Tunnel project was working with them is the time to explore the paper in concrete, for example. So not just because we have a lot of paper around, we put that material, but there are cellulose fibers. Let's take some tensile strength increase, which we are seeing that as well. Textiles, I have a couple of slides very quickly I'll show, but the tensile strength increase, not just, we know putting textiles or paper will drop the strength, but however, that strength, there are ways of, I'll mention how to bump up the strength. There are other ways we are working on. But we had to use the positive properties as well. That is why the fly ash picked up. Now, some of us going around and talk about high performance concrete. We had the fly ash. We said put fly ash to every structure under the substructures. Really, so there were, and also workability improvement in fly ash. Sorry, I'm going everywhere, but fly ash now we need to think about what to do because we are closing down the coal fire plants. What do we do? So I have another student starting to work on the alternate materials for fly ash. So there are areas where we need to really, otherwise we can't really continue like this. So with how do we to achieve all that? So reduce consumption. Of course the other things are quite known. These are all probably obvious. The recovered construction waste, the concretes, the metals, we need to work on the steels, all that, the recovered resources, asphalt pavings. We had a lot of discussion on the asphalts today in the conference. That's one of the easiest ones to really have been done already. Clump rubber in asphalts, been done. So this is relevant to this, everything we are doing. The CEO of the Tire Stewardship Australia said that, you know, when she was saying, I don't know whether Richard, you were there when she was saying, but was saying that the 10 years they had put crumb rubber in asphalts, and that they have some evidence that is working. So they said, don't worry, just use it, but because 10 years. So they have spent some time. So we are starting with some other new materials. So we need to do some accelerated work. I'm again saying these are quite important. We can't wait for 30 years for durability tests to check. So we all have to think about some accelerated testing methods. And I will come to that a little bit later on. But roofing, bricks, I'll go a bit quicker. So these are, I'll just put down, which are really been every number of forums being discussed as well. But I need to look at the time most carefully. So the drivers, the policy. So the policy change, that's where Mr. Elmo, like, you know, what the government is doing, like, you know, the policy changes, the net zero targets, where we need to really bring of course, these are drivers. The policy, government has changed the policy now. That really is the driver. 43% from 35% to 43%. That's huge incentive for everyone to really go and look at it. And the banks are lending money. The carbon, the credit scheme which I have put, the SECU, you can study Australian. If there are questions, I'm happy to explain that. But Australian Carbon Credit Units scheme, which brings. So when you cost a project, when someone invests, they don't need to just put the dollars value. If I'm putting 100 million, but like now I'm investing 100 million, they can count the carbon credits as well as part of that return on investment. So that can be incorporated there. That will change the whole concepts of doing that. And again, happy to explain a bit more all those. We have started to quantify things, which really again, that one of the projects that I get involved at early stages, where I've been helping them to quantify certain things. But so the end of life, where I'm going backwards, there are the drivers, but we had to think about the end of life now. So we are starting to think about not just end of life considerations, life cycle analysis. Now, what is relevant to a number of people here is we are designing the building still for 50 years. And when I was designing the telecom building, but we designed for 100 years because the client wanted 100 years. But Japan, they're doing 300 years. And one of so the bridges we have been doing 120 years. We had this discussion between the 3600 committee, which we had a committee meeting last week also, and 5100, there's the bridges separate, but we can't combine the two because bridges is 120 years. Our code, we took it up to 120, but still we are designing buildings for 50 years. And I was told there's one bridge at least in Brisbane, they have gone for 300 years. Japan has gone to 300. I don't think it's really, we have to go to that far. But so design life is important, but we need to think about what's happening with the design life as well. So carbon credits, we talk about barriers, procurement, processing cost. Is it all right if I take another 5 minutes to 5 to a bit more? Yes, how many minutes I should take? 5 to? Yeah, 5, 6, 7 minutes. Okay, 7. Sorry. Sorry. Okay, sorry. So, barriers. Otherwise, I'll go on and on. But barriers are there. The procurement, procurement is quite important. These are keywords will come. Processing cost. They're all about, there are some cost issues as well. Mechanical properties, we need to really look at the mechanical properties. We need to do the durability. That's, as I mentioned, accelerated tests. Monitoring is quite important. We have to get involved as anyone in construction projects. We had to get involved from the beginning. So field applications, I talked about evidence-based like decisions, standards and specifications, quite important. And we know we need to start changing specifications. What I have done personally is in the Concrete Code Committee, 3600, even last week, I managed to get approval to start a subcommittee to look at, I'll be leading that one, these waste materials when it gets to concrete. Are there any clauses? I'm happy to get any input to that. If you think of anything, please let me know to start into. I already started thinking about certain things, but So we need to start thinking that 3600 or whatever standards to be changed. The steel standard, green steel, we are going to green steel. I don't have even time to talk about green steel today, but the steel standards, we need to look at it. We are talking about high strength steel, so have some saving, that high strength steel. Using 700 MPa or whatever, can have some saving, will be fine. So saving some cement by, which I've got a quick example. So research and innovation, collaborations, we have working as a team is quite important, both really like the academia, industry, everyone together. Okay, I have not even started that. I have a list of things. We know already about waste and recycling, about the numbers. We are going into plastics and glass. Which we need to do some work. Australia's behind in recycling, so we need to really look at a bit more. Now, Europe has led the world, as we know. Europe has been thinking about it for a long time. US is not bit behind us. One way they would like it when I say this, but it's all right. I could have some online people from US joining today. That's all right. But I was there in 2019, just before COVID. My thinking is they are not doing too much. So rubber, and we know rubber and glass, the issue. I'll skip that one. There are opportunities for insulations when you put rubber to many other applications. So we need to look at the positive side of it. This is really a bit of our projects. Just to mention, we're working with the largest plastic recycler in Australia. To Mr. Harry Wang, to thank him. We have a CRCP project, Dr. Kasul Chanaka leading that. What we're doing is to really convert the plastics. Again, there are a number of issues there. So he has the biggest plant in Somerton. That's one of we're proud of that achievement, where we converted that recycled plastic to pods, where for the house foundation especially, so that, because at the moment they're using EPS. EPS can't be used in the future, the polystyrenes. So we can't. So we have to really convert that into that. So that is, we have a patent. Dr. Shanak has patent working with ARC Reinforcing. Actually, in this case, they were partners of our center. So these innovations are necessary. We are using AI now for waste identification, working with Mr. Harry's like factory. I'm sure he'll accommodate anyone. We are working on robots, visions, and AI integrations, and all sort of very high-level work. And some of our team members are here as well, working on that. This is graphene concrete is 1 minute on this. It is really the one that we use to really bump up the strength of the lost by the waste materials. So graphene oxide is water soluble. That's huge, and that company is working very closely with us here. That's the project on that. But so it's really there's an increase of the compression strength. So if we put graphene oxide to some of these waste materials, then really we get the extra strength, and we'll have a bit more information on this in the next a few months. There's a factory we are coming from. Sri Lanka has the purest type of carbon, 99% purity. So you get really the best graphene oxide, cheapest product. That is the problem up to now. That's why it didn't pick it up. But now we got bulk production there, and we are one of their main providers, research providers. So we have done a trial in another place where we put all sort of plastic. I call it fruit salad slab. We put all part of this, but they're using all sort of. So we can do all that now. But we need to. This is also slab on ground. It's not a structural slab, I would say. But we put it into some columns, the graphene oxide. Let's go through quickly. These calculations, quantifications are quite important. Again, to see your calculations are showing we can reduce the cement by putting that. So this quantification is very important. I will not go through in detail. I take a lot of time to explain. But you need to calculate the carbon numbers. We have to start looking at to think about the alternatives. We need to do these numbers. So that even the next hour will be around. So we are happy to explain how it's done. That's again the solar panel project. We are converting the used solar panels to really thanks to Mr. Niraj Das from the Elexam. He's having a factory in Kilmany, about 2 hours away, close to Sale. That he started building that factory where we have again vortex processes, put the solar panels, and then convert the glass. We are using the glass. It's pure glass we get. there are some issues. There's some lead in that. So we can't just go and say, I will, solar panels, just break it and put it into concrete or any other place. You can't do that because there's lead in there, lead poisoning there. So this is the process. Elect some company you will hear a lot about that. There's a launch on the 26th of October in the All Energy exhibition. So we know solar panels will pick up a lot, and what do you do with end of life for the solar panels? So we're getting good glass out of that. And the other project is, I think we already said that, but anyway, the last one I want to mention is also, we are changing the cladding of these buildings, the hazardous cladding. We have a separation process there with another CRC project, acknowledged Mr. Batmarsh. So it's really, we have a separation process of cladding, separating the HDP and aluminium, and then we are really converting that into plastics to concrete. Aluminium is used. Is pure separation we get. Also, we are even thinking of some shoes, the plastic shoes. So it's not just the construction applications, but I'm sorry about these blitz of things. This is a paper project I already mentioned. We put paper. We looked at 5 types of paper, and then we looked at lots of work we did, trying to put it to concrete, wet processes, dry processes. Finally, we arrived at some solutions. No one has used in the world the paper in concrete. So right now, this could be, we may get it to another metro tunnel temporary slabs. But so the last one, the textile, as I said, the textile is also, people are not used in practice too much because of the strength reduction. And so this work, I think also your work as well, but getting to putting the textiles to really having those reductions in strength. And I think, so last time, but I had to acknowledge the team here. I've got a large team here as well, number of present in here and then online, a lot of people joining. We can do this work is because of that, the hard fundamentals and get into the basics, even getting into the to the micro level of concretes, because unlike before where we could just go and mix cement and aggregates and all that, and we know we make the concrete, but we can't do that with this. Once you get these newer materials, recovered materials, we really need to, not only just concrete, even other areas, we really need to look at the fundamentals as well, go back to the characterization into that level, understand the material, and then try to, so see the tensile strength increase there, is there with the textile content. And the compressive strength, there's a drop in, are you getting increase in compressive strength? No, it's a drop, yeah, that's a drop, yeah, of course, yeah, sure. But anyway, so it's really, so this work has to be done. It's just, we are just starting to do these things, but I think to get textile, we've got lots of textiles, as we know. So to really, we can use it in concrete. So my last message is, don't throw the materials just because they are waste materials, but we need to look at the positive properties as well. And today I'm only giving projects on concrete, but we have a green steel project as well. So green steel is a key one for the future in our area construction, because they're using for processes. Yes, one side they can use the renewable resources to really reduce the energy consumption. At the same time, we need to look at how the steel can be used as well. Today, when I didn't talk about composites, but so it's an opportunity now for us to having some extra knowledge really helps. So I think that's why we all are here today, to learn a bit more, because someone